Okay, so today I'm going to talk about indexing Common Lisp with Kite. My name is Jonathan Godbout, and this is for the 2020 ELS, European Lisp Symposium. We are going to start off with an introduction, followed by some motivation. I'm going to give you an overview of Kythe, some output and tools to use the output of Kythe, some challenges in making the Kythe Lisp indexer, and some future work. First, about me. I'm a software engineer working at Google, working on QPX, which is the flight search engine, which is powered in part by Lisp. I'm a maintainer of Lisp cones, which will teach you how to program in Lisp. I write a blog, and I'm a PhD candidate at the University of New Hampshire, working in pure mathematics. And here is a silly little one. Okay, so first, if you don't want to watch the whole video, Kythe is a pluggable system for creating annotated code graphs in multiple languages. We have developed a Common Lisp indexer plugin for Kythe. Most notably, it's for SBCL. This will allow you to create UIs with jumped definitions, and it will allow you to see the signatures, as we'll talk about later. We are working on open sourcing the plugin, so you can stop listening, or we have 24 more minutes, so you can keep listening if you wish. First, some motivation. It's often you have code across a very large code base, and this can be hard to navigate. On GitHub, you have this verbose function in Basal Lisp. You can look right here. So you want to know all the places that this is called. Well, you have a few options. You can download all of the files locally and then grep, but that will give you all of the textual places that the function occurs. You can use slime to meta dot, but that will only be for the files you have loaded in your REPL. And what if you have a huge code base that will require you to load many gigabytes of file? And what do? Even on GitHub, you can do a search, but it's just a textual search. So here in this Bazel file, which is just Python, you see verbose, but it's not the Lisp function verbose. It's just the text verbose. More so, I can't even give you a link to that function. I can just give you a link to the line number. But that might change, and that's not useful. So you can get around some of this by requiring the language to be Lisp, but even then, you don't know if it's this verbose or a different function verbose or a variable verbose. Like we see in this declaim. That shows up. That's in Lisp. Okay. Our tools should help us. Our tools should tell us all of this information. We should be able to click on verbose and get every reference. We should be able to click on verbose and get every function reference, not variable reference, not in-text reference, but every place the function verbose occurs. We should be able to right-click on verbose and get a link directly to verbose. Left-click, probably. We should not get any Python or Bazel or C++ reference, unless we want cross-references, and then it should tell us. We should get the actual Lisp function verbose calls. We should not have to compile all of our code into a REPL. Okay, so with motivation out of the way, what is Kythe? Well, from Kythe.io, Kythe is a pluggable, mostly language-agnostic ecosystem for building tools that work with code. But what does that mean? Kythe is a database of code annotations to reference across a multi-language code base. Now, by pluggable, each language develops its own indexer plugin to Kythe, and Kythe just asks the plugin to analyze the file. It's used at Google to get cross-references for data across a very large code base. We've developed a Lisp plugin for Kythe, so we can add Lisp data to the Kythe database. Okay, why is this useful? Well, you have an at-rest index of your code. You can serve cross-references and create called graphs, all with a static database, all with a static code base sitting in some repo. Okay, so how does Kythe encode this data? Well, as I said, Kythe needs to be able to incorporate facets of many languages, C++, Python, Lisp, many languages. To do this, Kythe has nodes and vnames to uniquely identify those nodes and edges between the nodes. Now, I find it best to illustrate these nodes with an example. So we're going to take the function thread p from Bordeaux threads, namely impl-sbcl.lisp. Okay, so on line 25, we see defun thread p object, type p object, sb thread. Okay. Now, we're going to look specifically at this object right here. This, we will create a node. It has a ticket, which is just the URI encoding of vname down here, which we will discuss the next page. It has a kind. This is variable. So this node is talking about a variable node. So you'll have another node for anchor to say where in the code it is, but this is describing the variable object. Has language, Lisp in our case, a name, namely object, a qualified name, object. The difference between name and qualified name is name might be object, but qualified name might be package, object. But here this is a locally bound variable, so it doesn't have a package name. Okay. Now, before we go to the next page, I briefly want to say corpus. Corpus is the largest part of your directory. So it might be all of GitHub, or it might be your company's repo. It's the largest thing, the kind of the root you want to index from. Okay. Now we have the sub-objects location. Location is where in the code this is. So we see the corpus, the path to Bordeaux threads, source, SB impl. The line number, here is line number 25, so that checks out. And it ends at line number 25, so that checks out. And if you actually check, you'll see it's at column number 16 and column number N22. And it has a vname with a signature, the corpus, the path, and the language. So that's supposed to uniquely identify this node. Corpus, we've talked about. Path is path, and language is language. That has to be there. What's different between languages is signature. Every language has to identify its own signature. Now, since this is what identifies the node and what you really need to understand, if you want to link to things, you want signature to be makeable, preferably by other languages. This is hard because of the uniqueness constraint, and there's no good answer. C++ does a hash and of several things. In some cases, we use location. So that's one of the difficulties. Okay, so we've discussed nodes, but this is a graph, so we also want edges. An edge looks like, as we would expect, a source, which is a node, a target, which is a node, and a kind. So if you look at this function, thread p, it has an object argument, and it uses the argument in this type P. And we would like to be able to we would like to be able to mouse over object and see the other object down here. So we'd create a second node. So node 1 would be our previous node, and node 2 would be another node of kind variable specifying this object. Then we would highlight object, and we would actually see the other object being highlighted. And this is exactly what it looks like. Now, there's a large schema for Kythe. You can annotate multiple things. You can make a node for docs. Please go to IO doc schema to see more. Okay, so what does this get you? Well, since I can add nodes for doc strings and I can add edges for documents, I can actually click on, say, standard IO bindings, the global in Bordeaux threads, and it will give me the documentation. We see here's our doc string, standard bindings of printer. We see the path, and we see what the variable actually looks like. We can also specify function arguments. So here we have the function make octet vector, and it has arguments octet count and initial contents as a key. And the doc string. It's a long doc string, so I cut it off. And that's in brown base. Okay, we can do more than this. We can also make call graphs. So here we have a call graph. This is for the function call within new thread. That calls make condition variable, condition wait, condition notify, make lock, and with lock held. Note this is taken from Bordeaux thread source impl-sbcl.lisp. The 2 here says that there are 2 things that call make lock in different files. So here, there's 1 thing that calls make condition variable. Okay, so we have doc strings, we have function signatures, and we have call graphs. Okay, so you can run Kythe. So Kythe is currently implemented to build and run with Bazel, which is the Google build system. You can find at bazel.build. There's a Lisp plugin for SBCL. You can find it at Kythe Bazel Lisp. We're working to make a new version. Kythe uses a dependency graph created by Bazel so it knows what to compile. So Bazel goes and it looks at a build definition, and it says, here's all of the dependencies. So it goes and finds all the dependencies of your file and sends that to Kythe. And Kythe then sends that to the individual language analyzer. So in our case, the SBCL Lisp indexer as an analysis request. What each language does to analyze a file is up to itself. In our case, due to macros, we actually compile the file and we use the who-calls database for cross-references and some extra parsers, as we'll discuss later. What's nice is we also store doc strings in slots, in functions, and globals. So we can easily get these doc strings just by looking at the who-calls data, just by looking at the function slot in memory. Okay, and so if you want to build graph data, code graph, you can use Kalegraph. Kalegraph is an open source graph database. It's a NoSQL graph store, so you can do all the querying you could ever want. And you can also use Kythe's command line tool. Okay, so how do we actually make these nodes? What's under the hood of the indexer? We call compile on a file and all of its dependencies. We build that into an then we build an abstract syntax tree out of the file. Thankfully, with Lisp, it's fairly easy because Lisp is almost already an abstract syntax tree. And then we do a depth first search, checking each node as we go to see whether it's a file, to see whether it's a function or a variable, where it's referenced, by looking at the who-calls database. This gives us quite a lot. It gives us non-inline functions. It gives us macros and setf calls. It gives us doc strings. And it gives us global variable references, except for some things at top level. So there's one thing you have to be careful about. In your image, you already have the indexer. So if you change any of the code in the indexer, and then you try to recompile, and then you try to index that file, it's going to blow up because Lisp can't redefine constants or structures. So you have to be a little careful. But we miss many basic things, right? You miss function arguments and bindings. So if you have this function foo bar baz, you don't know that bar and baz are bound. It's not in the who-calls database. Like let bindings, if you have let foo tick bar, you don't know foo is being bound. Same thing for flattened labels. And loop bindings are, well, just silly. Very so you miss these. Language specifically, you might also miss things. There's no reason. So SBCL doesn't use the traditional setf function, and there's a comment in the SBCL structure code. And so we actually have to manually make the setf accessor references ourselves. This is not optimal. What we do is, one of the steps of going through the code is finding every place we have a def struct and actually adding them. It gets worse. The reason we love Lisp is because it's powerful. The macro system is a big part of that. You can either say Lisp has no syntax or Lisp has all the syntax. In most languages, you don't have this. The syntax is given to you. You know how bindings are going to look. In C++, modulo the macro system, you know where the bindings are. And even then, the macro system in C++ is fairly weak. You can still fairly easily tell what's being bound and where. Now, the Kythe indexer for C++ doesn't handle macros well, but they're not very complicated. On the other hand, you can do whatever you want in Lisp. You can do string cat if you wish. So Lisp allows the users to define whatever syntax they want whenever they want. Here's a basic example. Process data mutex. So I want to write multi-threaded code, and I want a macro that binds this mutex. So I make my mutex. I make a macro with data mutex. As we see, it just binds the mutex and continues on. And I have a function, process data, that binds the mutex and uses and outputs whatever format tilde is going to look like, and then prints a if a is bound somewhere. Okay, in this function, with data mutex, how do I know that data mutex is what's being bound? If I look at the macro call, it looks like it's body being bound, this body. Well, thankfully we put the ref body there, so we know that that's the body of the code, and so it's not being bound. But it's not obvious what's being bound. And you can make heuristics, and to a large part, that seems to be what Slime does in a lot of cases. But it's really hard to get perfect references with Lisp macros. And you can even imagine anaphoric macros and making more and more complicated examples where it's impossible to tell. So we really don't do this well. We also want interlanguage references. A common case at Google is with protocol buffers, which is our on-the-wire message sending system. Oftentimes outside of Google, you use JSON. So what happens is you make a protocol buffer file. So here we have hello world.proto. We're going to use proto2. Don't worry about that. The package we're going to be in is example. And the message is going to be hello world. We're going to have an optional string, hello world string. We would like to know everywhere. So this is going to create for us a def struct, hello world, with a slot, hello-world-string. And we're going to make an accessor, proto2, hello-world-string. We would like to be able to highlight over hello world string and see everywhere the accessor is called. Now, if you know the vname, this is simple. Because every time you see the accessor in the code, you just make an edge for references, and you get exactly that. The big issue is you need the vname, right? Vname is what uniquely identifies a node. So what they do is the protocol buffer indexer actually omits the vnames in a little bit more data so you can make these references. Okay, now why should I use this? As we were saying, this lets you create cross-reference data from many file, many language repository. Imagine having all the cross-references for all the Lisp code in the world, at least as long as you put it in one repository. You can even get the CFFI calls, so long as you can figure out how C++ uses its vnames. It can be used to produce call graphs. You can make these jump definitions outside of an IDE. So on GitHub, you can click verbose and find every place verbose is used. And you can add the data to a graph store and do queries. My future work, I'm working currently to open source the Kythe Lisp indexer. It's already out for C++ and Java. You can go here and use it to your heart's content. You have I would like the Lisp indexer to work with other Lisp variants. It'd be nice to work with ABCL and get Java cross-references. It'd be nice to work with CCL, and it has a nicer database for who calls. And I would like to make a generic macro parser. I have that as an intern project. And I'll take ideas if you have better ideas. I was thinking a code walker that goes out and calls macro step expand. I would like to thank Jinwoo and Anjay. They wrote a lot of the indexer before I even joined Google, and Eric for writing a lot of the parser before I even joined Google. Ron and Carl went over the conference paper, and Carl went over this talk, and many indexing CLs. I would like to thank my wife and my daughter, and thank you for listening. Here's the citations. I hope you've enjoyed.